organized by Northeastern University, NAMU, and computer applications in collaboration with COMYS Educational Trust, Kolkata. International Conference on Data Electronics and Computing. The primary objective of ICDEC is to provide, the main objective is to present the latest research and results of sciences related to communication, networking and security, image, video and signal processing, cloud computing, IoT and smart city, AI, ML, big data and data mining, VLSI design, antenna, microwave and control. The prime objective of this conference is to bring all the delegates to a common platform to exchange new ideas and application experiences in the field of electronics, computing and dynamic Now, I request Professor Head of the Department, Electronics and Communication Navy, to welcome our delegates.
A very good morning to all of you. It's my privilege to welcome all of you on this bright day over here on this auspicious occasion of International Conference on Data Electronics and Computing. First of all, I would like to welcome all the conference team over here. A very good morning to all of you, sir. I'm not taking the name, otherwise it will take time. Then I would like to welcome all the participants for coming over here and attending this particular conference. So welcome you all. So on this particular occasion, I would just like to briefly give a detail of our department. The Department of Electronics and Communication Engineering, it was established in the year 2006, and it was started with the course of Bachelor of Technology, and then in 2013 onwards, the MTech course has also been included, and then subsequently the PhD course is also been included. So now we are offering all the three courses, Tech, then MTech as well as the PhD. And we have produced nearly 1,000 students in last decades, and all of them are well established around the globe. So this is a happy moment for this particular department that we are in collaboration with Consys team. We are organizing this particular conference. So this is a happy moment for us. So I once again welcome you all and hope these 3 days will be a very enjoyable day for us as well as for all the participants. Thank you all.
Thank you so much, sir. I would like to express my sincere gratitude to our technical corporation, computer chapter, IIIT, Kolkata section, publishing partners, Treasure, financial sponsors, Intel Silver sponsor, Patronet LNGs Limited, Diamond and Discount also. Now, I request Chair Session, Dr. Ram Sarkar, Professor, Department of Computer Science and Engineering, Jadavpur University, Kolkata. Dr. Sarkar is a leading researcher in the field of medical image analysis, computer vision, deep learning and image technology. oceanography. He has authored over 300 articles in record journals and conference proceedings. He received the highly prestigious Fulbright Medal Fellowship for Research at the University of Maryland, USA. I request you, sir, to kindly join us.
Good morning, everybody. Today we are starting our Tutorial-1, session 1. So here our speaker will be Dr. Kishorjit Nongmeikapam. So a little bit about Dr. Kishorjit. So he was working as head of the department, Computer Science and Engineering Department in Indian Institute of Information Technology, Manipur, India. Previously, he worked at Manipur Institute of Technology, MIT. He has obtained bachelor's degree in computer science and engineering from PSC College of Technology, Manipur, Tamil Nadu. He has obtained his master's degree and PhD degree in computer science and engineering from the Alvin University, Kolkata, India. He has published more than 65 peer-reviewed papers on national journals, international journals, conference group chapters, and in different proceedings. In the field of machine learning, NLP, computer vision, image processing, he has also authored the book the C programming. He has teaching experience of more than 18 years. Presently, he is supervising 6 PhD scholars. He completed different projects from Department of BSc, Government of Manipur, India, presently working on another 3 major research funded projects like multilingual reference wordnet on 4 of the major indigenous dialects in Manipur and Manipuri language, funded by ACRB, EST, Government of India, a prototype of auto-navigating e-card using multispectral imaging, funded by MEST, Government of India, and ISAN, a system of bidirectional machine translation between English and Assamese, Bodo, Manipuri, Nepali, Manipuri, and Hindi, Assamese and Bodo, a consortium project funded by MEST, Government of India. His main research areas include machine learning, natural language processing, computer vision, and image processing. He has delivered more than 35 employment talks and attended more than 50 workshops, seminars, conferences. Also, he has been a member in the technical committee, editorial board, reviewers in many conferences and journals. So, with this, I welcome Dr. Kishorjit. Please come. Thank you.
Now, share with you this.
Like, I would like to talk
uh, in the area of natural language processing, because it has been a very hot topic as of now. Like people have started doing research work on robotics, computer vision, all these things. But the only part which was lagging is like how to interact with the robot in such a manner that the robot becomes almost like a humanoid or something. So this is a very interesting area. So I try to put a topic as a walk through various paradigms of natural language processing and machine learning. Because like here, I'm trying to put up from the basic till little bit of deep learning, so that everyone who are very new to this can also understand what is natural language processing. That is my target here. Like I'm not going to just discuss specifically on one particular topic. So like when we try to do something, we try to bridge our natural language with the machine. So that is the main thing here I just want to discuss. Because like we have a game between our language and the competition, really. Because like we try to communicate, we try to communicate with the machines through mechanical mechanism. But now what we can do here is that we can just communicate with the machines through our own natural language. This is the motive. This is the motive of natural language processing. So what we have done is like in order to just go for this conversational sort of thing through natural language, we need to have some concept of what you know about programming also. Unless you know programming, then we won't be in a position to just communicate with the computer. That is the philosophy. Of course, at the end of the day, one day, people may be in such a level that you don't need to program at all. Whatever you talk, the computer is going to listen. The computer is going to understand. Whatever you want, you just chat with the computer, and everything will be solved. Not in maybe like in the future, you don't need to program at all. That is the concept. So now, if we start talking about natural language processing, we can think of three axes. Yes, of course, we can just work in basically in three classical concepts two classical concepts like through vision or through speech. Maybe like you can have a concept of text also. So that is the basic platform where you can work in NLP. Now, when you just have this thing, you can again have another three axes where you can have, the language, not normal language, the natural language, which we talk. Like, say, for example, English, which I'm talking about, or the Kasi, which you used to talk, the Manipuri, which we used to talk, the Tamil, whatever it is. So, there is a parameter or there is an axis where you have to speak your own language. That is one important thing. Another thing is like, you have some problem. Our problem is that we are supposed to communicate with the machine. So where should we start? Like, in order to learn a language, a school child has to start learning from ABCD. So going from ABCD, then he has to move on to the grammar. Then again, the next thing, 70th level, whatever it is. So we have certain problems in that. So that is another axis we need to think about. It's not only about the language which you speak. You need to have a problem. That is what we are going to solve. And that problem can be solved through different algorithms. And like we have different algorithms like starting from HML, then we have CRM. Now the stage is that we started moving to deep learning and all. So that is the thing where we have to focus in order to learn the natural language processing. So where all it starts. Thing is that basically, whatever we learn through machine, we will just basically move on with the probability, because probability teaches everything to us, starting from all learning. Say, for example, if I have to learn something, if I have to teach something to a student, a small child, basically when he comes to the art, that child doesn't know anything. So what we used to do is the parents started talking something to the environment used to teach something to the child, because the child used to repeatedly listen to some voice in his ear, in his or her ear, the child's ear. So, for example, the child used to start talking. Used to utter the first word as mama or papa, because that particular word is being repeatedly inserted in that child's ear, because which means like the probability keeps on increasing. Because looking at a very large set of sample, the event of calling mama and papa becomes very frequent. So the probability becomes very, very high. So we have to start the concept of learning, machine learning or something from the basic of probability. So let's have a basic concept of probability. This is what we all know it. Like we need to have a sample space, then we need to have some event. Like event is being counted based on the sample. This is what everyone knows. Mathematically, this is where we start. Now, probability, like if you have to just define a probability, that it's something like it's a law where something like you have to have something which happen very frequently, or otherwise you can say something like it's a chance of getting something out of certain samples. That is the idea behind probability. So now here. Why I am talking about all these things is because we are trying to just insert the concept of this probability in the context of learning something by a machine. That is a basic philosophy behind why I am talking about the probability. Say for example, if I have hidden coin, if you toss a coin, what's the percentage of getting a hit or take? This all everyone knows that it's like 0.5 because you have a certain chance of it. So that is the concept of getting, learning the probability as a basic technology. Now, what about getting the same thing in the machine learning or otherwise in NLP? That is the meaning. Like we have to go for the number of events out of the total outcome. Say for example, forget about this because we here. See, like we have started learning the NLP here itself. Like in the NLP, like the robot or something, the computer started. If suppose the robot has to identify a verb in a sentence, how will it happen? Like we have to find like the way. How many verbs can be it can be counted from the last sample of corpus. That's where it started getting the concept of NLP for finding a verb in a sentence. So this is a simple concept. So you have to have a huge corpus where you need to identify a particular verb. So here starts the concept of NLP. So here all the words insert like you need to have a very huge corpus in order to identify whatever you want. It's a sample of a verb, but you can go for a noun, you can go for a preposition, you can go for a pronoun. Because once you want to translate something from one language to another, then you need to identify the part of speech for the first step, especially for any of the language. Especially for Manipuri, we have a little bit difficulty not only in finding USA, but otherwise we have to go for some sort of morphological analyzer. Why it is because is that Manipuri being a Tibeto-Burman language, which is of highly agglutinative. Say for example, if I take a word called which means like this is a simple single sentence, single word. But if you have to translate it to English, it will almost become like a sentence. Like that very particular word will become something like this. Like I wish I would have asked him to do so. So like there is a difficulty when you have a very complex word. So in that case, you have to go to the basic of finding the morphemes in that particular word. Morpheme is just like it's almost like a syllable, but here in the morpheme, it can be of multiple syllable or a single syllable, which gives you a meaning. Syllable may sometimes doesn't give you meaning at all. Say for example, unlikely lady or something. Lady, for example, lady is a two syllable, but morpheme wise is only one morpheme. Lady itself is a meaningful one, which means like it's a morpheme. But lady, the lady, so there is two syllables here. So we don't need to go with the syllable, but we have to go with the morpheme again, morpheme level again. Identifying morpheme in a particular word is also another problematic one. So there also you have to apply some sort of probability and all. So here, let's start with the concept of probability and then applying to other objectives of natural language processing. So, see, this is another way how you can apply NLP, probability in NLP. So, let's consider W1, W2, W3, all these W's are to be the words. Now, I have to find something, maybe like a word, a word prior to certain phrase, or maybe a word following to certain phrase. So, like, I have to, find out a particular word given some other words. Particular word given, which is given with certain other words. So, in that case, if we take some example here, say for example, the sentence is like, the other day I was walking along and I saw a lizard. So this is, there are certain words here. Now what I am going to do is, I am going to state whether this, maybe will be prior to the other phrase, or like that. Similarly, I have to keep on checking all these things. Like the first and most simple example will be like applying to the chain rule in probability. So, everyone knows like how to just go for the chain rule again. Like chain rule, if you go for the chain rule, you have a probability. If you have to find the probability of A, B, C, D, then you have to go with this formula. So this is the chain rule. And once if we are supposed to apply this chain rule, then again, what happened here is, see, the last line. So the big red dot was, if I have to find the probability of the given the big red dot was, then I have to find all these things. So the probability will become like probability of the probability of big given probability of big given the probability of red given the big. Like see, I'm just talking about this probability because we have to have a very huge corpus. Huge corpus will just give you the samples which I was talking about in terms of probability. So unless you have a very huge corpus, this will not work again, because like this probability is going to count when you have a very huge corpus. By corpus I mean like a very huge collection of sentences. So that is the beginning of it. Now this is another example here when I have to say like the prior to the phrase like its water is so transparent that its water is so transparent that. So in that case, what we are going to do is we have to count the number of its water is so transparent that this number of phrase should come. I mean, we have to count the number of phrases which happen to be like this in the huge corpus, divided by the count like its water is so transparent that. So then we will be able to find out like what is the probability of getting its water is so transparent that the following word the. So that is one thing. Now going on with the relation with NLP and all this automatic speech recognition, thing is like this basically NLP can basically work both in text and speech. So that is the reason why I have given the diagram where you can just work on speech also, you can work on text also. Because language is not only on text, you can work on speech, then convert it to text, and then text can also be converted to speech also. Like that. Once you get that, you have area where you can work for NLP. And nowadays, what people used to do is, even in NLP, they try to, bifurcate, having another area called NLP, natural language understanding, where this will be more specific to what we know about NLP. In NLP, we started talking about the basic concepts. Now we are more in depth with the concepts of NLP, where you will start thinking about sentiment analysis. Because like sentiment analysis and all, the machine doesn't have sentiment at all. The robot doesn't have sentiment at all. Because like the robot doesn't have the concept of love, the concept of sin, or something like that. Like they don't have emotion at all. But what people are trying nowadays is that they just try to insert emotion to the machine also. Because like even in the science fiction movie, we used to come across like humanoids where the robots started loving some other people. So that is the concept people started infusing things. In that case, we need to know what is sentiment. So sentiment analysis is a very, another important area or interesting area where people can understand and where people can do research for. Not only that, you have all this there are different things like going for the semantic level also. It's another important area where, because when I talk about Washington, maybe like when I use the word Washington, Washington can be the president of India, Washington can be a place name, Washington can be a name given to some animal or something, whatever it be. In order to identify what is this as Washington, I mean, there is some ambiguity there itself. So in order to make this ambiguous, there is another important area where we can discuss about this NLP. And that part, we just make it into NLP. That is nothing but natural language understanding. Now, techniques which we generally use for the natural language, in the natural language processing, basically we start with the rule base. Because classically we started learning things or infuse the algorithm to the machine through rule base. Because by natural language we already have certain grammar, certain rules. Straight away applying that grammar, converting it to some program, that is what we call it as a rule base. We don't need any extra thing. Even the grammar rules, we started designing the algorithm and then implementing. That's the rule base. And moving on to the second phase is almost what we have discussed a little bit also, where it will be a probabilistic base. Probabilistic base is just like statistical methods, where you find all the things based on some probability. So that is the statistical method. Now we move on a little bit to something called the advanced method, where you started talking about deep learning, all these things. Starting from ANN, artificial neural networks, and keep on moving. And now we are moving on to deep learning. Now we have data science and all. So the rule base is a very simple logic for the rule base, because you have a grammar, you have a rule for the natural language. Only thing is that you are going to program based on the rule being provided by the linguist. So you have a language, because in this case you have to work with an expert in that particular language, because he or she will give you the rule. You are going to set the program, and then that will be run. But the thing is, in the natural language processing, the rule doesn't make that much accurate. We don't have 100% accurate with the rule, because in the computer, it's not like we don't have that much flexibility. We don't have that much flexibility. Thus, we need some advanced techniques sometimes. Yes, of course, for the English, like for the stammer. For example, if we have to go for the stem sort of thing, for the stammer have designed a very good algorithm, especially by this English one, I would say, because based on the formula he has set up, that all the English word can be stemmed properly. We don't need any statistical method, we don't need any advanced technique. So that is a very good example with the rule base. But now, when you go for the machine translation, like if I speak in English and if I have, the system has to automatically translate into another language like Hindi or maybe Manipuri or maybe Kasi, then there arises the complexity which is more in requirement than the rule base. Because rule base is generally, it lines with the linguistic concepts, but it cannot be implemented 100% with the machine. So we need something which is beyond this rule base. So you have to start, if you have to start working with NLP, it's better you start with the rule base, so that you will be having a chance to understand the language. You will have a chance where the visits are. Then, say for example, this is a rule-based language for my language. Like I have given you the example, meaning of this word also. This is like our language, especially the Manipuri, is a very agglutinated language. Agglutinated in the sense that it is that the word is being, having a lot of suffixes or maybe affixes. Okay, for this you will find around some 11 suffixes here. The root word is two only. So we have a two, which is a root word. To take. Who means to take something. Okay, when I said usil hanjaran gadabani, like this acts almost like a sentence in English. Then you cannot just straight away translate with what you have in your rule base. Yes, of course, for the stemming, you can just have a rule base where you just remove all the suffixes what to say, all the suffixes which is here. I mean, suffixes in the sense like you have o, you have the, you have ni, all these things, you keep on removing all these things. Then you will find last word called tu, which is like, which will be the root word. So like, this is the way how you can start. And now, even for this also, you can just add up to some morpheme also, morpheme table, where you can just walk with the morpheme, because like each and every suffixes which I have been removing, they are almost a morpheme in all languages. It may not be a syllable, but it will be almost like a morpheme to my language. But this can be another example for other languages. So this is how you can start with the rule base. Now, statistical methods. When you talk about statistical methods, it's basically based on what you call as probabilistic methods. In the probabilistic method, starting with the one which I have discussed, we can move on with all this n-gram and all. We have already know like what is an n-gram. Well, in the n-gram, what we are going to do is we are going to get a particular word, or maybe a combination of words. We are going to check it out whether this particular combination of words comes together or not. Say for example, whenever we have something like to work or something, like you have a to, then what will be the following words? There may be a chances of getting something like eat, something like go, something like generally a verb or something like that. So we are going to check it out. Like the one which we are having about a very particular word, lovely, and then followed by how many, the following words. Maybe you can consider one word, you can consider two words, you can consider three words, and basically you can have multiple words. Thus we call it as n now. So you can have n number of words. But the problem here in the process of NLP is that when you go for multiple words, the thing is like the system will become more heavier. It will become heavier because like you have to keep comparing with multiple words. Getting for one single word doesn't matter. Two doesn't matter much. When you start moving with three words, then it starts the complexity because the system will become heavier and heavier if you keep increasing with the number of n. Say for example, see, like this is the formula, of course, like you can go for unigram, trigram, trigram, and quadrigram. Okay, now when you go with an example here, what I'm saying is that I'm going to find the unigram for each and every word. Because like the main from Jupiter, I'm going for the unigram. If you go for the unigram, it won't make much sense for you because we are considering only one word at a time. But when you start talking about the bigram, you are considering two words at a time. Why I am considering two words at a time is that in the English or in any language, in a huge corpus, what we are trying to find is we are trying to find the pair of words which happens frequently. We are going to come up with the conclusion that when we have this sort of word, then it is almost like the probability is so high that this will be very, very correct when you write any language. So that is the concept. So like the main from Jupiter. What I'm thinking is like I'm putting an S because S does mean that it's the starting of the sentence. So I'm trying to find the probability of the starting the sentence in the bigram, for example, if I consider it bigram. Okay, I'm checking out the probability here. I'm trying to check the probability here that is there any chance of starting the sentence with the? Yes, of course. The probability will be very high in this case because much of the sentence in the huge corpus you will find the sentence starting with S. So that is you have to find a probability here or probability here. The another thing is that I'm trying to find a probability of main given the which is like the main. And you're going to have a huge corpus. Corpus are having a very huge corpus in terms of lakhs of sentences. In that sentence, I'm trying to find the probability like how the main is there, how many times the main is there in that huge corpus. People are using the main, which means that it's almost true, it's almost right. That is the thing, that's the statistical way how we are dealing things. The main. Then another thing is like main from. So main from will be, the probability of main from will be very high. you are having a very huge corpus. So that is the thing, that is the way how you can just find it out. Same with this, even you can just apply checking the syntax of a sentence. Like most of you might already come across MS Word when you type something and if the sentence is wrong, they are used to underline with a red line, which means like the sentence structure is wrong. So behind the scene, there is some algorithm like this, where the sentence correction, for that sentence correction, there is something behind the screen, behind the screen behind the GUI which you are observing. The algorithm is almost like this. The probability, based on some probability, or maybe some other algorithm also. This is one of the classical algorithm in order to check the sentence structure. Okay, if you go for the trigram also, we are considering three words at a time. So in that case, the probability of getting more accurate becomes higher and higher if you increase the number of gram. So we are talking about the trigram, which means like I'm considering 3 words at a time. The problem here is, yeah, this is another example, like for a diagram. Say for example, I'm taking out a corpus of 9,222 sentences. Okay, so now the thing is I try to create a matrix here, which means like I want to eat Chinese food non-space or something like that. If I get a sentence like this, the thing is like I have created a matrix of it, where I'm considering a bigram, which means like I. In this number of sentences, getting of continuation of I'm getting only 5 times. If I talk about I want, I'm getting not a probability, a count of 527 times in this corpus, which means like there is a high chance that I want doesn't have any error at all. We don't have any chance of discrimination here, because I want generally used to happen in any of the English sentence. There is nothing wrong when you say I want. That's how you started finding the bigram here, the number of counts here. Then I2 will never be there, because the sentence structure now in English, we never speak about I2 like that. Then IE, like it's there, IE is there, but here in the sentence, I'm getting very less number here. Then if you check here like 1, 2, and 1, 2. You are having a very good number of count here, which means that the count of number when it is increasing, that means like the following word, the consecutive word seems to be very, very close to each other, which means that like there is no chance of getting the error. You can just jump to a conclusion in some cases that the sentence structure is right or wrong, which means like the syntax can be. You can just predict the sentence, whether the sentence is right or wrong. So this simple example. Nowadays we have different methods. This is a classical method which we can just deal about in order to check, by applying the right. Now, moving on with the same thing with the probability again, then the higher one definitely will be getting the higher probability. Once we have a higher probability which is close to 1, definitely tells you that the following words is almost a consecutive word. Thus, this can be a very good example. Now, see, this is the way how we have been talking about. Sentence starting with I, then I want to eat Chinese food, and then food as a last sentence. So this is like a diagram sort of thing, a type of diagram in the checking of the sentence, syntax of the sentence. Now, why we don't want the higher version of n graph? Look at the last statistic here. If you go with the unigram, you're comparing only 10,000, because if you have 10,000 words, you're comparing only 10,000 words. When you talk about bigram, you are comparing something like 10,000 into 10,000, which will be like this much huge comparison you are doing. So when the system is comparing this much of comparison, definitely it will become heavier. The efficiency will become, it will start decreasing. Now if you go for the diagram, it's almost like something like this much of comparison you are going to get, which means like this almost a very big deal for the computer, because we talk about the efficiency of the computer, because based on based on the thing, I mean, like when we talk about efficiency, which means like the output should be in a very short time. When you compare this, when you make this much of comparison, then the output will take definitely, the output will definitely take time. So we don't need to go the higher n now. If you keep on increasing n now, the number of n, value of n, then definitely, yes, of course, the accuracy will be high. But the thing is like that denominator will become heavier and heavier. So that is the way, that is the reason why we started talking about applying till diagram or something for the application of NLP based on NLP. So then you can apply again the name-based also, because this is another classical method where you find this is the thing which we have already learned in mathematics, where you find a name-based rule where this will be almost like a chain rule, then you will be having some conditional probability here. Because like you will be having a probability which is being given, I mean, based on some other probability. If you want to find a probability of A given B, there is a condition that you will have another probability of B, which is like we're conditionally depending on the probability of B. So that is the concept. So based on that, applying the same rule, then you will be able to find the best rule. Extending the best rule, you will have the name best rule. Of course, we already know this algorithm also. This formula was mathematically we have already gone through it. Now, let's see with some other thing. Like this is another interesting area because I was talking about the sentence level. Now let's move on to some other level now, where we'll try to find the other sentence. Okay, other sentences like if someone has written some document or something, there may be a chance and we are not in a position to identify who the other is. There may be circumstances like that. Because like maybe like I have few articles with me, few documents with me, or otherwise maybe forensic science. Say suppose like someone has written something, and now I have identified who has written that particular document. Like in that case, what happened? What we're going to do is we can apply this name-based rule in order to identify which document is that, or which document it belongs to. Or otherwise, we can just go. I mean, classification of some classes. Like in the computer science, we have a topic of subject of category classification or something where we use to identify the class on it. So here, I'm going to do something here where we are going to identify a document which I would like to classify whether it's a Chinese document or it's not a Chinese document. Because like say for example, I'm having a document here, I'm having 5 documents here. I got some idea from document number 1, document number 2, 3, and 4. Where the first document says like, in the first document, it says like the first document is a Chinese one. The second document, because like being these 3 words in each document, like being these words being there in the document, we confirm that it's a Chinese document. Again, in the second document also, there are words like Chinese, and Shanghai. That also we consider that that's a Chinese document. And then third one, Chinese Mekong, also that is a Chinese document. These are few things we observe. And then the fourth one, where I find Tokyo, Japan, Chinese. This proves that this is not a Chinese document. So I am having 2 classes now. One is a document which will be a Chinese document. Another one which will not be a Chinese document. Now, interestingly, the 5th document, I don't have any idea whether this particular document, document number 5, belongs to Chinese or it's not a Chinese document. In this case, what we are going to do is we are going to apply the name-based rule. What happened here is we have some formula here. We have to start with the probability of Chinese. Okay, here number of documents we have to go, and then the number of documents in the class C. So that is how we have started identifying the word Chinese, and then whether it's a Chinese document or not. This particular word, and it is a Chinese document. I mean the word Chinese, and then the class Chinese. I mean China. So I found some value here. Now for the Tokyo being in Chinese document. The word Japan in the Chinese document, and I found some probability here. Now, the word Chinese, and not to be in Chinese document, I found some probability here. Then once I find this probability, now I am going to identify this very particular document which have the word like Chinese Tokyo, Japan. Here I find a very interesting one here with the probability, and being the vocabulary of the document, we can just observe that the probability in the first case is like 0.0003, but in the second one, the probability of not to be changed is like 0.0001, which means that the probability of to be in change is more higher than the one which is not being changed. Thus, we can conclude that this very particular number 5, this particular document number 5 is almost oriented to a Chinese document. Thus, we can just simply implement the concept of all these things in order to identify finding the author of some some article also. Because generally it starts in maybe in 1950s when in US, somewhere in US, because like when there was a news stream, most of the editors they used to write articles by articles, articles after articles. But some of the articles were authored. They don't have any author on them. The newspaper has to identify who had written that very particular article. In that case, someone has to go with some rules or some norms in order to find the authorship of that very particular article. They basically do it through the vocabulary content of that very particular for that particular article. Because like the one which I usually used to write will have a very rich in vocabulary. If someone, Mr. X, might have used a very low quality of vocabulary. Based on that, they used to identify who the author was. Interestingly, that concept we can just implement by using some algorithm in the computer science. So this is one of the examples. We have different methods also, different techniques also. This is one of the simple examples. Then we already know about conditional random field also, which we call as CRFs. So this is another advanced way of finding things from the little bit a higher level from the what you call as the probabilistic method. This is of course a probabilistic method, but a little bit of advanced technique. This is the formula where there is a weight given here. It should, the arrow should point here. And then another thing is like we need to have certain features in sense like some characteristics in order to identify something. Okay, so this feature is what is very important when you talk about NLP. Say for example, in the Manipuri, what I have done is we have identified the POS for a Manipuri word, phrase, paragraph. I'm just giving a scientific example here. Like when you find this word, then it is a noun. This word is a verb, something like that. So every word is being given certain taking. This is an automatic take being based on some algorithm. Because in Manipuri, if I have to go for a CRF, as I mentioned, like there are some features here. In this case, in our case, I have listed out some features here. We have experimented with these features, and then we bring up some accuracy in the Manipuri POS technique based on the CRF. Now, based on that algorithm, we have designed a system, and then we have identified this one. For English also, you can find it in the Stanford University website. You have a US data, automatically US will be there. With that system, you can go through the Stanford University website, NLP page, and then you'll find the algorithm for US taking, especially for English. For Manipuri also, we have for Hindi, there are people who work for it. So this is another level where you can start working for NLP. Because once you know the power of speech of each and every word, then you become closer to the machine translation. Unless you know the concept of what is this particular word, it will be very difficult for us in order to make the translation from one language to another. So this is one important basic tool for whoever want to work in NLP. Then this is another application of probabilistic method or statistical method. Here, applied the support vector machine. Basically, this is also another mathematical oriented algorithm where you are supposed to find, say for example, you have some class here, this is one class and this is another class. This may be noun, this may be verb. So you have two class now, one is verb, one is noun, one is verb. And try to draw a line in between these two classes. Maybe I'm talking about linear one. There is a linear algorithm for SVM also. Let's talk about the linear one. Like I'm trying to draw a line here. But the thing is, like I can draw multiple lines passing through these two classes. Maybe with different orientation. So this is like we may be thinking like this, but there are chances that we can draw multiple lines in between in order to classify these two classes, like the noun and the verb. We are supposed to find the best line, one of the best line, so that we can classify these two classes. So that is the concept, applying SVM in the identification of all this, maybe part of space taking or maybe multiple expression or whatever. So this is like in here, what I'm going to do is we are going to find a particular line which gives equal distance to both the class. Thus, we have to find out this line, and then we have to just conclude that this line is the best line. And thus, we will be able to identify the particular class. Say, so this is another example of SVM where we identify the name entity, because name entity is another important thing. When you want to go for translation from one language to another, in English it is so simple. So simple is just almost easy, because the names are generally started with capital letter. Names are generally, or whatever it be, nouns are generally started with proper nouns are generally started with capital letter. So it's easy for that. But for what about for the Indian languages? We don't use any capital language. Then we have to identify the particular name in order to go for the translation. Because sometimes name used to be a very, very meaningful one. Because like say for example in English, in Manipur, for example, if we have a word Chab is a particular name of a person, but it has certain meaning, semantic meaning. Semantic level, if you go to the semantic level, if you start translating a particular word, then the translation will be in chaos. That is that we need to identify the name first. And those names which is being identified doesn't need to translate. So this is another area where people used to work. Then we apply SVM, then we identify the name entity for that particular sentences and where that particular character. Once you get that one, you don't need to just go for the translation of those identified name entities. So in here, say for example, Dr. Manmohan Singh is a very particular name entity. Then by name entity, we have to go across the name of the person, the organization name, maybe the money, the date, all these things we consider in name entity. Because like, say for example, if by mistake, if you haven't identified an organization name, then it will be another chaos in the translation. Because when you translate things, generally the organization names are being given with something meaningful one. So that should not be happen for the message translation. Another identification is necessary here. So we implement SVM for the identification of naming. So this is another area where we can work out. Then the advanced methods. We talk about the advanced methods. We talk about starting with the CNN or otherwise ANN, starting with ANN, artificial neural network. We already know about artificial neural network also. Then we have to go deep inside and what we call as the deep learning. Okay, so let's talk about all these things again here. For the ANN is so simple. It's a replica of the human biological neuron. When we talk about the neuron, where you have dendrites, you have synapse, you have nucleus, all these things. Then we have a different output for that. So that is basically it starts from this concept. And to be very frank with you, whatever algorithm we get, in much of the algorithm we get in computer science, basically it's all dependent from the day-to-day life. Much of the algorithms are designed from or otherwise adopted from what we used to observe from day-to-day life. Because like this is a new area of the computer science and engineering is a very new engineering area, comparing with all this mechanical engineering, civil engineering. So that's like what we did is like we used to adopt algorithm which is already there or which physically available. So this is one classical example of that, where you have where we have the concept of neurons and then you adapt it. So like this, the neurons and all, we already know it. Some of you might be very new with it, but still, the concept is almost like the same. You have certain inputs here. The thing is like you are going to finalize it with certain weights and all, and then you are going to get an output based on the inputs which we are having, and then the weights, and then the algorithms or something which is supposed to be calculated. Some functions are there, and you are going to get an output for that. So this is one implementation or a unit of what we call as artificial neural network. Now, okay, this one slide over there. Now, this is like when you know about deep learning, this is again an advancement of what we call as artificial neural network, or otherwise then a little bit a movement towards CNN also. Okay, so now in the deep learning, what we're going to do is you are supposed to have a network of all the neurons. Here we're going to have multiple inputs, and then we're going to have multiple layers. Again, you have an output, but the problem here is that, or otherwise the uniqueness of this deep learning is that you will have certain hidden layers. Hidden layer in the sense like this will be something which will not be able to identify by the general organism from the layer of input and output. It will be something like this is there as a unit inside the algorithm. So like that way, say for example that in the classical NLP, what we did is like we have language detection, then we process it, we model it, then we find the output. Now, and I was mentioning that only the rule there is not going to work. And another point I have mentioned is that we have to little bit depend on some probabilistic method also. And then I have mentioned something about that we need to identify the POS, NPR, and something which is passive tools. But here, when you talk about deep learning, now when with the deep learning and the advancement of deep learning, we started translating without knowing all these classical concepts of POS taking, NPR, all this. We are not depending on this thing at all nowadays. We started talking about neural machine translation, which I am not giving this time. In the neural machine translation, what we did is we never depend anything based on all those classical concepts of POS taking, then NER, MW, morphing. We are not depending anything on that. We are purely depending on some parallel corpus, where you will have a parallel corpus, which means that you will be having one language, and which will have an ultimate translation of that very particular sentence to the language number 2. So the two parallel language will be, parallel corpus will be an input for the neural machine translation, and then you will find an output based on the vectors being designed on that. The system will automatically formulate the rules by learning from the parallel corpus which we will be supplying. Okay, that was of the advancement we have done it nowadays. We don't need to go with the classical method which I have been discussing here. But anyway, to be more interesting, let me just give you one more example side of what we call as the deep learning. Here in the Manipur, we apply again another method here called deep neural network. We started infusing 3 layers here, and then we try to find the output. Here we try to embed the morphemes. Then we have another biaxial network here, and then we have the time distribution layer here. Based on these 3 layers, which will be a hidden layer, if we talk about the deep learning. So based on these 3 layers, we try to find the output for the especially the POS. All these things can be applied. So here the 3 layers are like embedded layer, where the word embeddeds are being done. In this what we have done is, like each word is mapped to an appropriate level value vectors. which means like we are having corpus which we will try to make each word with a proper speech. Then because like the Manipuri is a agglutinative language and we generally depend on the suffixes also, so we try to just have an embedding for each suffixes also. So that is one layer. The second layer where we call as bialism. Okay, this one, what we have done is we try to just try to find the previous one and the second one. We try to just have a bidirectional concepts here in the bialism of the word which is before and the preceding word and the successive word. So based on that, we have another layer. And the third layer is the time distribution dense layer. Here, as for the power speech taking, what we did is we have many classification problems. This is the layer which we have generally neutralized that word. And thus, we just go with the output based on that. This is another application for the deep learning. Now, the thing is that if you have to differentiate between machine learning and deep learning, in the machine learning, that use statistical method and every machine to improve the experience. But in the deep learning, what we did is like we started using neural networks with multiple neurons, and then we try to find the possibilities. And other thing is that we try to have some hidden layer too. So that is the difference. Now, if you look at the diagram, like how it all works, we started talking about AI because there was no machine learning at all at the beginning. We started talking about artificial intelligence, which is nothing but a normal searching algorithm. There is nothing like learning something, it was just a normal searching algorithm. You have a problem, you have to search for the best solution. That was the thing, that was the rule which we started learning with the artificial neural network. Now, in the artificial intelligence. Then, moving from artificial intelligence, from normal searching algorithm, we started having the machine learning, where machine started learning automatically, based on some statistical method. And then, nowadays, we start going with deep learning, and then we go for neural machine translation, and thus it will keep on going also. There is no limit here, because maybe the next day we will be having another algorithm, which will be more advanced. That is the progress of computer science and engineering. Well, like comparing it, as we have been learning, like comparing with the pace of how this computer science is advancing. If you compare with mechanical engineering, the mechanical engineer would have designed some flying cars by now. But the computer engineering is so advanced that it's so fast where we don't have much time to keep learning or to keep sticking with some certain algorithms. That is the point. Now, what about programming with our natural language? This is the ultimate question which we can ask for the future. Because nowadays, when we talk about computer engineering, people start talking about programming. And we have to learn programming, like C, C++, Java, Python, whatever it is. We keep learning programming. But there may be a time where we don't need to learn programming. The system will program automatically. You need to talk only because you started talking, you started having chatbot and all. Chatbot where you have to check with the system, type something wrong. Chatbot will automatically start replying something. But in that manner, there may be a day where you don't need to program anymore. The system will start learning itself and then it will start programming itself. So that is the future. That is the future. So if we have to start really have to start working on NLP, we basically can start with all these basic tools like USDT, chunking. Because like we don't need to straight away jump to the advanced techniques. Because if you straight away jump to the advanced technique, we may miss something. So best way is like we have to start learning from all these basic tools. Then we can start talking about message translation. Then even like we can have automatic speech recognition also, because this one people have started learning long time back. Now we can have it we can infuse this too, like working with ASR and then one which we are talking about, that is message translation. Once you infuse this together, then you can have a normal humanoid or maybe like something robot which you can just be a replica of a human in terms of a machine. Okay, so that may be the thing, and you can have a natural language with which you can communicate with the machine. So that is the future, and that is the ultimate goal of what we put as natural language processing. So conclusion is that we need to have a little bit of mathematical logic if we have to work on natural language processing, because basically only the rule-based doesn't work. Then we need to keep on checking out the advanced algorithms. Not only that, we need to keep designing new algorithms based on the language, because the language the algorithm which I have designed and which I have applied in some language may not be applicable to another language. That is another thing. So then, machine learning is another direction for self-learning. Because self-learning will be the ultimate goal, because people are dreaming of something which can assist us, some gadget which can assist us by Another example is your Alexa or something, where you have to have a word with Alexa, then Alexa will be, choosing whatever you want from the Google. Okay, so that is another example of advancement in natural language processing. So that is another thing. So like generally humans are very, very lazy, because like whatever we do, we try to find shortcut only. Whatever we want comfort. Whatever we are going to design, we are going to design it for what comfort only. This comfort will definitely, maybe one day will bounce back, which may be very, very drastic to us. Who knows, like robots started killing us, maybe like robot will understand what our body is. Robot will understand what our sentiment is. And then they will target all the humans one day, maybe possible. Because in the defense sector, they have started putting robots. And then these robots can start deciding on their own, like who to kill and who not to kill. Who are the enemies. They have put up such a technology in the robots that the robots started deciding who the enemies are, who are not the enemies. In that circumstance, why not? Maybe one day the robots may start killing us, shooting out like they are. They started thinking that humans are the enemy for them, and then they may start killing us. That may be another future. So that we need to be very careful when we started designing all this algorithm. So one day the machine may start talking among themselves. They may start designing an algorithm among themselves. They can start designing an advanced algorithm, maybe a very, very, very deep learning among themselves. They can design something which is very, efficient among themselves, which will be very scary to us. That's it. And I suppose, like much of you have enjoyed what NLP was, because this was a tutorial where I started from the basic and I started to pull you a little bit towards the advanced technique. This is how this NLP works. Thank you everyone, and if you have any query, please.
Okay. So thank you, Dr. Kishorjit Nongmeikapam, for your nice presentation. The topic is really very hot topic, natural language processing, and you have started with very basic one like the rule-based, and then net-based, support vector machine, and then you go deeper like neural network and deep learning models. So I think the audience they'll gain some good information. So if you have any question, you can please ask our speaker. Anybody?
Sir, there is a village in Meghalaya. There is a village in Meghalaya.
Okay, sir.
Its name is Nongmeikapam.
Okay, sir.
There people used to speak in whistle language.
Okay.
Now government wants to preserve that. Now this particular community is going ahead and they started speaking in their Khasi language like that. They are naturally forgetting this type of language. Now government wants to preserve this. Okay, now NLP is not an aptitude, this algorithm for the purpose. I think speech processing is the appropriate tool for the purpose. Speech processing. That means they are speaking in whistle. It means something.
Okay.
Now with the how and we have to decode it.
Okay.
And we have to preserve this whistle language so that when I write something in English, the computer will make the corresponding whistle out. So how that can be done? Is it the digital signal processing thing?
Yes, sir, the frequency response. Like we can, as we have suggested, like maybe then suppose they have some written language, written documents. Yeah, like we can just process it and I mean, we can just work in both the ways. We can start working with the ASR and we can switch on information also. Where in that case also you will require a huge corpus. A huge corpus. There you can start it because if suppose they have documentation, you can start collecting the documentation. All documentation. It's wide language. Only one. Then you can start with the ASR or something, ASR model. For the ASR model, definitely you will have a huge corpus. Corpus, but at the same time, you need to collect the voice samples, lot of voice samples. Then once you have the voice samples, then you can just design an ASR. Once you have an ASR, then you can go for the conversion from speech to text again. Once you have that speech to text conversion, then automatically you can have a good, what to say,
Actually, a sentence based on noun, verb, and object.
okay.
Now, verb is the main, one of the main given. Past, present, and future tense. Okay, these are the three tenses. You can tell them to speak in what is the reason. Past tense, present tense, and future tense. You can find out which are the prominent frequencies coming out of this by using signal processing technique. Here also, but we do the clear processing.
Definitely, we need a investigate the frequency
patterns. So these are the frequencies which are present in past tense, not present tense.
We need to have a linguistic concept here again. If we have to go with, on this change and all, we need to have a verifier. The verifier will be the linguist. So we have to get some linguist in order to verify what we're talking about, like future, past tense, and present tense. Only our work will be something to design a system where we can just move on with all the things which I have been discussing.
Our system is simple. Computer, I'm speaking English, and computer will communicate English. But think this like for us, like for NLP, basically we require English. For further verification, I can speak in Khasi, or we will be in English.
I think that this is a of limited vocabulary. I think
No, they
what natural
they have a meeting in English.
how to
Unless you modulate your questions accordingly, and it has a large number of vocabulary.
And they say that it's not voice body. Their name is a particular concept. And when that point dies, one particular frequency is gone. They cannot use it.
I suggest one more.
That is the thing they are carrying on. So how
I suggest one more. Like now, there is a message translation, an empty method called neural message translation. You don't need anything basically on all those linguistic concepts. What you need is you need to prepare a parallel corpus. Say for example, Khasi and then parallel corpus, where you need to have Khasi and then particular language. Once we have the parallel corpus, we can move on to the neural message translation. Then in that case, you don't require all this something neural message translation. That is the most advanced one.
frequency will come because this is which one? It's a frequency, game of frequency. This is a game of frequency. And it can be decoded. We can any language.
Yes,
We
yes.
also speak about this.
Definitely, sir. But we need to understand that.
They use some frequency modulation.
Yes, yes. We can work on it.
We can work with it. That's a mixture of speech processing and AI.
Yes, maybe.
Maybe I don't know.
That's why we can work on it. Yes, of course, someone is interested.
Okay, Dr. Kishorjit, there are some online questions, so you can see the screen. Mr. Subhas Arya, he has a question.
I talk about that one now. Well, I started talking about Subhas Arya. I talked about some advanced technique where we just applied some deep learning methods and all.
Okay. So already it has been discussed.
I think we need to type something.
In one of the slides, all three names are mentioned as words. So first it is unit based, another one is classical based, and third one I am forgetting. So that is question. How deep learning and artificial neural network, which are the advanced methods. And think one of the slides is there. I mean, let's see what.
Probably they will receive the slides also. The audience.
Sir, I mean, the bias is because there's other advanced technique has come up, there is some theory. But the the bias.
Yes, yes. So this is a basic part which I am talking about. They have different, there are different techniques also.
Yeah.
So popular is listening in my voice is listening to me. Yes. Because I have perspective.
Yeah, but an online question, they are listening to you, but they cannot answer.
Okay. So like for the question which we have asked is like what is the third method? Like specifically in this tutorial I mentioned something like an advanced method where we try to discuss about the deep learning. So maybe like now in the advanced method we can even go for neural-based translation also. So I think this satisfies the question.
Okay, so is there any more question here? Okay.
Something about the arts of speech timing is mentioned something there in the website. So you have to know what each of the words are in the sentence, like the word and the preposition. So those things, if you don't do that are in this knowledge prepared. So maybe we have a purpose. And then in that context, because these words go to these words, prepositions. So then those that are related to me, does it have to be now or does it have
Designing a purpose, like generally we start designing with purpose on email. Okay, because like usually we have some standard in the purpose actually. When we differentiate the purpose in terms of silver, gold, or something. If we are talking about gold standard, the thing is that it should be very, very clean. Like the pre-processing, at the time of pre-processing, it should be very, very clean. Like in which someone has to verify 100%. Once you get that, then the thing is, nowadays that we need to have some verify. The used to be very we cannot do it. Yes, of course we can correct some because in terms of something like silver level, where we can 100% security. So once you want to design something 100%, you have to be for the whole system. So you want to do this, increase the size of the university. You want to use it they always. Yeah, you can just do the size. You don't need to increase the size. You increase the size, whatever you
Okay, so is there any more question here? Anyone? So I have one or two simple questions. You are talking about different deep learning models which now you are using in NLP. You are working the local languages like Bodo or Manipuri, some regional languages. So for standard languages like English or Chinese or maybe some other European languages, we have some pre-trained deep learning models like if we use transfer learning concept. So do you have the same kind of pre-trained learning models if we use the local languages like Bodo or Manipuri?
Yes, sir. We started applying all those things because even if we apply those subjects, the thing is like we need some modification. We cannot just shift the domain which is being applied to some English or something. So we need certain changes without going. depending on the language, complexity of the model. Thus, definitely we can apply, and we started applying.
I mean, you are creating those models,
Yes,
and
yes.
you are.
Yeah.
So, if somebody wants to apply these models, so do you have the options to get this online? Like standard models, we
Yes, yes.
get this online.
Yeah.
So, for local languages,
Yes,
so are
yes.
you providing this?
Yes, yes. The thing is like we need little bit of modification in between. Online, what we are having, we need little bit of modification in between. Otherwise, based on the context of the complexity of the language, as I told you, now for us, we need to depend on the morphemes. So when we go for deep learning, also we have to implement the characteristics, features, implementation. We just go with the morpheme level. Thus, we apply like that. But we don't need that much of this, identification of morpheme if we go in English, maybe Hindi or something, like depending on the language.
So another question is that you have discussed mostly about the classifiers or the classification algorithms like support vector machine or neural network or even the deep learning models. But in case of NLP, there are many problems which do not belong to the classification.
Yes.
Like if you translate or if you want to generate something or the summarization. Okay. So these are not part of the classification. So for that,
definitely. We are implementing even in the summarization also we are implementing. If you go in the summarization also, all these things are applied. Because I'm just giving you for the part of speech taking. But if you go for the summarization, the phrase, all these things are supposed to be classified. Extracted to certain classes.
So I have not much idea about NLP, so just I'm asking.
For the summarization, it says like if you talk about summarization, which means like a huge document has to be summarized, condensed into some certain sentences. Which means like I'm going to classify certain words which is of importance. So we are going to have two classes, one class which is important, one which is not important. Based on that two class, we are going to extract the important one, and then we are going to have the abstract one. Then summarize. That is the way how we do it.
So my last question would be like you are working on the translation also. So when you translate some regional like novels written in Bengali or Manipuri, so suppose you want to translate it from Manipuri to English. So what are the main challenges you face in translation?
For us, like main challenge is like which I told you, like morphic identification is one of the main challenges because like translation, if I'm in Manipuri, we have only one word, but whereas it will be like it will be one to many sort of thing.
Yes.
English will become multiple words. So maybe like
the context would be different in that case.
Based on Manipuri, so it's very complex sort of thing. But from English to Manipuri again is another complex one. From many to one word. So that sort of thing we have to think about.
Okay. Okay. Thank you. Thank you, everybody. Okay. So there is some announcement for you.
Thank you so much, sir, for your valuable and
Kishorjit, please come.
interactive session.
Please go to the stage.
I request session chair Dr. Sarkar sir to felicitate our key speaker for today, Dr. Kishorjit Nongmeikapam sir. Thank you, sir. Now I request Professor sir to felicitate our session chair, Dr. Sarkar sir. Thank you. Now I request everyone to join us for a short tea break, and we shall be starting our next session